Alright, so here we are, continuing to solve trig equations of a single angle on the interval 0 to 2 pi. Now I do want to point out, I didn't really mention this in the last video, I don't think. Single angle, so you will see things later on in an actual trig class where you're solving equations with a number in front of the variable, and that would not be a single angle then. If it's a 2, that's a double angle. If it's a 3, it's a triple angle, and so on. Or you could have a half, and that'd be a half angle, or a quarter, and that'd be a quarter angle. We're not doing that in this class. And also on the interval 0 to 2 pi, we will learn, or not we, you will learn in, again, another class, how you can solve trig equations with no interval and still write all of the infinite solutions. So we're not doing that here. All right, first example. 2x squared plus 3x plus 1 equals 0. And 2 sine squared x plus 3 sine x plus 1 equals 0. I want you to try this on your own. If you understood what we were doing last time, you should be able to do this. But my hint is solve this first. So think about how to solve this equation first, and then use that to solve this equation. So pause the video, do that, unpause when you're ready to check. Alright, so hopefully you ended up with 7 pi 6, 11 pi 6, and 3 pi halves. How did we get that though? Okay, so first, the algebra up here, right? This is just factoring a quadratic trinomial. So this becomes 2x plus 1 times x plus 1, set each of these equal to 0, and I get x equals negative 1/2 and x equals negative 1. Okay, so if we understood that, then we should understand that 2 sine squared of x plus 3 sine of x plus 1 equals 0. And remember, and you've done this in a previous algebra class, I'm sure, what we call sometimes U substitutions, or something that's of quadratic form. And that's what this is, right? It's something squared. It's 2 times something squared plus 3 times that same thing plus 1 equals 0. So anytime we have that, that is what we call of quadratic form. Whether it's just an x, whether it's a sine of x, it doesn't matter. It factors the same way. So it factors into 2 sine of x plus 1 times sine of x plus 1 equals 0. Set each factor equal to 0. Solve. I get sine of x equals negative 1/2 and sine of x equals negative 1. Use my unit circle. Sine of x equals negative 1/2 at 7 pi 6 and 11 pi 6, and sine of x equals negative 1 at 3 pi over 2. Any questions? Okay. Moving on. Some jokes never get old. All right. This is going to be a little bit more difficult, but I want you to try it on your own first. If you get stuck, just unpause, listen to me ramble. Pause the video, unpause when you're ready to check. Think about the strategies that we've talked about though. Okay, now pause. Alright, so assuming I did everything correctly, which I make mistakes, so maybe I didn't, we get x equals pi thirds and 5 pi thirds. How did I do that though? Okay. So remember strategies, all right, get all the trig functions on one side, get everything in terms of one trig function if we can. Okay, well, I've got 3 trig functions to start. They're all on one side, so let's change it into 2 trig functions. So the first thing I did was I changed tangent of x into sine of x over cosine of x. Now, I thought to myself, okay, well, that created a fraction. I didn't really want to deal with the fraction. So one way to get rid of a fraction is to multiply everything by the least common denominator. The least common denominator is just cosine of x. So I multiplied the entire left-hand side of the equation as well as the entire right-hand side of the equation, because that's how I have to solve rational equations, by cosine of x. So when I distribute this on the left-hand side, cosine of x times cosine of x becomes cosine squared of x. And cosine of x times this term, well, that's the whole reason why I multiply by cosine of x, right? That's just going to cancel with the cosine of x. But sine of x times sine of x is sine squared of x. And on the right-hand side, I get 2 cosine of x. Now, look at this magic. Who saw this coming, right? Cosine squared of x plus sine squared of x. Boom. Pythagorean identity in your face. That's 1 equals 2 cosine of x. Now, how do I solve? Divide by 2. 1/2 equals cosine of x. Where does cosine of x equal 1/2? Great question. Unit circle. Pi thirds, 5 pi thirds. Boom. Done. I do want to point out, so another potential strategy that you might have taken, either way you probably need to do the same first move that I did here. Another strategy though, maybe you said to yourself, okay, well, I don't mind working with a fraction, and in fact, I kind of like it. So instead of multiplying everything by cosine of x, I'm going to get a common denominator. So you could have multiplied this term here by cosine of x over cosine of x, and then you would end up with cosine squared of x over cosine of x plus sine squared of x over cosine of x equals 2. Now you can get a common, now you have a common denominator. So this becomes cosine squared of x plus sine squared of x over cosine of x equals 2. And now the same thing happens though. This is my Pythagorean identity. That's going to turn into 1, and I get 1 over cosine of x, and that's secant of x. And so then I would say, well, where does secant of x equal 2? And those are the same locations where cosine of x equals 1/2. So either way it works. Okay. Solving trig equations.